Next example on Lagrange's method. Show that the greatest value of 8xyz under the condition x square by 9 plus y square by 16 plus z square by 4 is equal to 1 is 64 by root 3. That is, we have to find the greatest or maximum value of the function 8xyz. So we denote this function by fxyz, that is fxyz is equal to 8xyz, and this is the condition denoted by 5xyz. This is the condition right here, minus 1. Okay, and then we construct the auxiliary function that capital F is equal to small f plus lambda into condition. So right here minus 1, then here is also minus 1, x square by 9 plus y square by 16 plus z square by 4 minus 1. So this is the auxiliary function. Then differentiate this with respect to x, y, z and lambda. Same procedure. This procedure is same to every example, that after writing the auxiliary function, differentiate partially with respect to x, y, z and lambda. That is, if we differentiate partially with respect to x, then y, z and lambda are constants. So the derivative of this quantity is what? 8yz plus lambda, and the derivative of the this bracket is what? Derivative of x square by 9 is 2x by 9. Derivative of y square by 16 is 0. Derivative of z square by 4 is 0. So is equal to 0 and equating with 0. That is, differentiate partially with respect to x, y, z and equating with 0. Similarly, with respect to y derivative is equal to 0. Similarly, with respect to z derivative is equal to 0. And with respect to lambda, we have the derivative is what? X square by 9 plus y square by 16 plus z square by 11 minus 1 right here, minus 1 is equal to 0. This is equation number 4. So in every example, equation number 4 is the given condition. Okay, that is the differentiation with respect to lambda. Then from this step, there are two methods. That are what? The first method is discussed in the first problem, that if it is possible to find the values of x, y, z in terms of lambda, that is free from the value of x is free from y and z, the value of y is free from x and z, and the value of z is free from x and y. Then find the values of x, y, z and substitute in the last equation, that is the equation number 5 or equation number 4, that is the condition, and then find the value of lambda, and by substituting lambda in this equation number, we have the values of x, y, z. This is one procedure already discussed in the first problem in the previous lecture. Okay, but if it is not possible to find the values of x, y, z from equation number these 1, 2, 3 in terms of free from x, y, z, then next method, then this is second method, we can apply this second method. Okay, so in this example, if you find the value of y or z from equation 1, then it is not free from x, y, z. Also, we cannot find the values of x, y, z from which are free from x, y, z, or in terms of lambda. We cannot find. Here we have x from this equation, but in terms of lambda and y, z, so it is not possible to find the value of x in terms of just lambda, that is free from y and z. We cannot find the value of x, y, and z free from x, y, z, and therefore we apply another method for this example. This is the Lagrange's method. So what is the second method from this step? Up to this, every problem is similar. The problem of greatest value or maximum or minimum value of three variable function are same up to this step. That is right auxiliary function, differentiate partially with respect to x, y, z. Then from this step, we apply the second method for this example, that is multiplying the equation 1, 2, 3 by x, y, z and adding. So if you multiply 1, 2, 3 by x, y, z, we have this 5, 6, 7, and adding this 5, 6, 7, what we get? 8xyz, 8xyz, 24xyz, and take lambda as common. So we have, and 2 as common. So we have 2 lambda is common. Therefore, x square by 9 plus y square by 60 plus z square by uh, 4. Okay, we have this here, right? Z square by 4. The derivative of this quantity z square by 4. So right here 4. And then the value of this bracket is 1 by using the equation number, by using the condition or equation number 4. X square by 9 plus y square by 16 plus z square by 4 is equal to 1 in the next step. And then lambda is equal to minus 24 xyz. Therefore, lambda is this minus 12 xyz. Then put this in equation number 5, 6, and 7. That this lambda. So lambda, if we substitute lambda in equation number 5, we have this. Then take this 8xyz, 8xyz as common. So we have 1 at this place, and this 12 into 2, 24. And if we take 8 as common, then we have 3x square by 9 is equal to 0. 8xyz is not equal to 0. The multiplication of this is equal to 0 means one of them is 0. But 8xyz is not equal to 0 because we have to find its maximum value. That's why it is not equal to 0, and therefore this is equal to 0. And therefore we have x square is equal to 3, and therefore x is plus minus root 3. Similarly, substitute this lambda in equation number 6. In equation number 6 here, lambda, we have this equation, we have this, and then take 8xyz as again common. 12 into 2 is 24. We have 3y square by 60, and therefore we have the y square is plus minus 4 by root 3. Y square is 16 by 3 actually. Therefore, y is what? 16 root is plus minus 4 root of 3 divided by root of 3. Okay. Then substitute this lambda in equation number 7 here, and again take 8xyz as common. We have this bracket is equal to 0, and therefore z square is 4 by 3. Therefore, z is plus minus 2 by root 3. 2 by root 3. And therefore, the stationary point is take all positive signs. Therefore, we have value of x is root 3, y is 4 by root 3, and z is 2 by root 3. And the maximum value of the function, this is the critical point or stationary point. That is, at this point, the function is either maximum or minimum. But we have to find the maximum value, so we consider the function is maximum at this point. So the maximum value of fxyz is equal to, if there is no, in the Lagrange's method, there is no test to determine the function is either maximum or minimum at the point, at the stationary point. For two variable function, it is possible by using the second derivative test, that is find the capital A, capital B, capital C, delta, and then if delta is greater than 0 and A is less than 0, then function is maximum, and if A is greater than 0, then function is minimum at that point. But it is not possible in this example. So why we write here the maximum value? Because we are given that in the example, find the greatest value or find the maximum value. That's why we say the function is maximum at the stationary point. Otherwise, we say if there is a wording that show that the minimum, find the minimum value of the function, then we say it is minimum value. And if there is no there is no mention that it is greatest or find greatest value or find lowest value or find maximum value, minimum value, then we say it is the extreme value. Right here, the extreme value of fxyz. Okay, in the case, if the example, in the example, it is not indicated that find maximum value or minimum value, then write the extreme value. Here the maximum value of fxyz, that is, this is the function 8xyz is what? 8xyz. It is the function fxyz, and so substitute x and y and z are these values. We have the answer 64 by root 3, and that is we have to show the maximum value is what? 64 by root 3. Then next problem, find the maximum and minimum values of the function. This is two variable function actually, and the condition is given, but condition is given. So same procedure, that is, we consider this is this as fxy. Now don't write fxyz. Fxy is this, phi is this, the given condition, x square plus y square minus 4 is equal to 0, right? Minus 4 is equal to 0. Then we construct auxiliary function as capital F is equal to this small f plus lambda phi, that is 3x plus 4y plus lambda. Condition is x square plus y square minus 4 is equal to 0. Then differentiate partially with respect to x, y. Don't write here z and lambda and equating with 0. So with respect to x derivative 3 plus lambda 2x in bracket is equal to 0. Then with respect to y derivative 4 lambda in bracket 2y is equal to 0. And with respect to lambda x square plus y square minus 4 is equal to 0. These are equation number 1, 2. And so now there are two methods. The first method is applicable here. That is, we have the value of x from equation free from y and the value of y in terms of lambda. And then substitute these values in equation number 3, x and y. We get lambda is equal to 5 by 4. And if we substitute lambda is equal to 5 by 4 in this equation, then we have x is equal to plus minus this is 5 by 4 because lambda square is 25 by 16 means lambda is plus minus 4. Then write plus minus 6 by 5 is the answer. Then y is also from this equation, y is minus 4 by 2 lambda. Substitute lambda, we have plus minus 8 by 5. And then stationary points are 6 by 5, 8 by 5. If you consider both sides are positive, if you consider both sides are negative, then this is the stationary point. And then at the first point, the value is 10. And at the second point, the value of the function. The function is what? fxy is equal to given. So fxy is 3x plus 4y. We have the answer minus 10. And therefore, the maximum and minimum value of the function are 10 and minus 10. Okay. Larger is 10. Therefore, it is maximum value. Lower is the. So first find the stationary points and find the values at that point. The larger value is called maximum value. Smallest value is called minimum value of that function. So this is the problem for two variable function, but condition is given. So just two variable function is given, then apply the previous method, that is the second derivative test. That is find the value of capital A, first order derivative, second order derivative, consider first order derivative is equal to 0, and then find the stationary points or critical points, and then find the second order derivatives and their values at that points, critical points. That is capital A, capital B, capital C. When that method is applicable, if the function is two variable and condition is not given. So here the function is two variable, that fxy, but the condition is given. So we apply here Lagrange's method of undetermined coefficients. Okay. Then next problem is divide the number 36 into 3 parts so that the continued product of the first, square of second, and the cube of the third may be maximum. Let x, y, z be the required part of 36. So we have to divide this 36 number in 3 parts. So what are the parts of 36? So if we divide 36 as a 10 plus 10 plus 16, then 10, 10 and 16 becomes part of the 36. That is, their addition is, the addition of that, the three numbers is 36. Then we say, that is, if x plus y plus z is equal to 36, then we say x, y, z are the parts of the 36. So suppose x, y, z be the parts of the 36. Therefore, x plus y plus z is equal to 36. Then consider the function fx, y, z is equal to, let fx, y, z is equal to. That is, the function fx, y, z is what? The function whose value is to minimize or maximize. That is, we have to find the value of function, minimum value of the function or maximum value of the function. That function is the fx, y, z. That is, and we have to here divide the number 36 so that the continued product of the first means x, square of second, that is y square, and cube of third means z cube, may be maximum. Okay. That is, we have to find the maximum value of this function. That's why we denote it small fx, y, z. That is, we have to find the maximum value of this function. That is x, y square, z cube. And the condition is what? This is the condition. And denote it is by pi x, y, z. Pi x, y, z is what? X plus y plus z minus 36 is equal to 0 is the condition. Phi or pi x, y, z. Okay. Then we construct the auxiliary function. This remaining part is similar to previous example. Then this is 3 variable function actually. The capital F is equal to small f plus lambda into pi. That is, this is capital small f plus lambda. This is phi. Then differentiate partially with respect to x, y, z and equating with 0. X, y, z, lambda and equating with 0. So these are the derivative. Don't write this equal to sign. The derivative is what? Y square z cube with respect to x, lambda into bracket 1 is equal to this. Derivative of this quantity is 1. Similarly, with respect to y is what? 2xy square, y, not y square, because y square derivative is 2y, remaining x and z square as constant. And with respect to z, the derivative is xy square, and the derivative of z cube is 3z, z square, okay? 3z square here, right? Z square, okay? Here, instead of this z cube, right? Z square, 3z square, xy square as it is, plus lambda into, in bracket, no, this is the answer, this is the correct answer, that 3xy, y square, z square, lambda into 1. And then x plus y plus z minus 36 is equal to 0. That is the differentiation with respect to lambda is the given condition. Then multiplying equation 1, 2, 3 by x, y, z, and next is adding. So the second method is applicable here because we does not have the values of x, y, z in terms of lambda. That's why multiplying, the second method is applicable. Multiplying equation 1, 2, 3 by 1, 2, 3 by x, y, z respectively. Do we have the 5, 6, 7? And adding 5, 6, 7 and find the value of lambda. So lambda is this, x plus y plus z is 36, therefore lambda is this. And then substitute this lambda in equation number 5. Again, substitute equation number 5, 6, 7, lambda. If we substitute in equation number 5 and take x cube, y square, z cube as common, we have 1 minus x by 6, therefore x is 6. Similarly, if we substitute the lambda in equation number 6, we get this, and then y is 12. Similarly, if we substitute x, y, lambda in the equation number 7, we get this. Then take x, y square, z cube as common. This is not equal to 0 because we have to find its maximum value. And therefore, this is equal to, therefore z is. And therefore, the required part of 36 are, we have the values of 8 x, y, z are what? 6, 12, and 18. And then their addition is what? Addition of these three numbers is 36. And these are the numbers such that if we multiply 6 and into 12 square into 18 cube, then we have the largest answer. Okay, so no need to find the maximum value of the function. That is the maximum value. That is, if we substitute x, y, z in this function, we get the maximum value. But we have to just find the parts of 36. So the parts of 36 are 6, 12, and 18. No need to find the maximum value. Then the next problem we will see in the next lecture.